if we're training a machine learning model to try and predict something, if we train it on the wrong data, it's going to make the wrong predictions. That's just kind of a natural fact. Potentially, we even get to the point where we can build systems that will tell us approximately how long we've got until it will break down again. So this is what agentic AI and AI agents are going to provide to us. Is it just automation? No, it's a lot smarter than that. There would be no way to do that without having both kind of physics and data-driven twins working together. We don't want to do things, I think engineers naturally, we don't want to do things if we don't understand them. Democratization doesn't mean that we exclude the experts. If anything, I always say that the experts actually become more important because they become those central lighthouse figures that people build around.
Cool. Roland, thanks a lot for doing this.
No, thanks for having me. Really exciting.
Very cool. Today we'll talk about a very interesting topic, which is also very close to my heart, which is understanding AI adoption in engineering. So before we jump into the nitty-gritty of AI adoption, what it actually means, if it's necessary for engineering purposes to talk about AI in the first place, who are you, Roland, and what are you doing at Altair?
Yeah, well, firstly, once again, thanks very much for having me. So my name's Roland. So I work for Altair's technical team here in the UK. And I'm a solution specialist for our data analytics products. So Altair as a company, we have kind of three main strands to our business. One is physics-based simulations, primarily for engineering. Another is high-performance computing. And then the final is our data analytics and AI platform called Altair RapidMiner. It's also worth noting that just about 4 weeks ago, the acquisition by Siemens Digital Industry Software closed for Altair. And we're really excited by that and really excited for what that brings to our customers going forwards.
Yeah, super exciting. I mean, let us delve straight into it. AI in the context of engineering purposes or application. What does AI mean for us engineers? I mean, AI has different meanings, different definitions. Where do we even start?
Well, I always like looking at it in quite a kind of broad sense to start with. And really, all AI is doing, it's trying to effectively act in the same way that we might do. So systems and machines are acting really like humans. And this can be applied in a lot of different ways. And really, if we think about engineers and what we do, there's a lot of different things we do on a day-to-day. So maybe some people are creating designs. Maybe some people are just writing reports. And really, I think AI is all about whatever we're doing as engineers, but making it better, whether it's adding additional insight, maybe it's adding new capability, maybe it's just allowing us to work a bit faster. But I think at a broad sense, it can mean so many different things, but it's really enhancing our everyday activity.
Yeah. What do you think is the difference between the definition of AI, machine learning, data science, and what everybody claims to be that's going to be the latest hit in 2025 is agents?
Well, I always like to say AI really just lives in PowerPoint. It's quite a vague term, really. In terms of AI in general, though, I think I always look at it as different levels. We start off with our AI, and then we have different subsets. So machine learning is a classic one where we're trying to teach machines to make a prediction of what's going to happen without having to really be explicitly programmed to do it. So I have a bunch of historical data. I know what happened then, and I'm trying to train the AI to be able to predict what's going to happen come the future. Obviously, AI agents, that's taking a lot of different parts of AI. So generally, we will have some form of large language model in there. So that's usually there to interpret what it's directed to do, what we direct things to do. But then it's calling upon loads of other things. It might be calling upon machine learning to go and make a prediction. But it might also be just preparing some data sets for you and fetching those, or using some combination of all of these different tools together. So I think it's just an extension of what we've already had, but also including this large language model element to make them really kind of super easy and super accessible for everyone.
Yeah. I mean, from my understanding, and you're the expert here, Roland, is that the data preparation part is the most tedious and the most annoying, but also the most critical part in an AI pipeline when you're building it. Why is it so crucial to begin with? I mean, we all heard the sentence, right? Garbage in equals garbage out, but can you be more explicit about it? Like, why is it so important?
Well, I totally agree with that statement that garbage in does equal garbage out. And really, what we think, again, if we draw the parallel to humans, if we're given bad information, we make bad decisions. Like, if you can't make a decision about your business or your day-to-day activity if you're not provided the right information. And the same really goes for AI. If we're training a machine learning model to try and predict something, if we train it on the wrong data, it's going to make the wrong predictions. That's just kind of a natural fact. And the same is true for these kind of AI agents and large language models, in that they need to be provided the context to be able to provide useful insights. So if you're, let's say, wanting to build a chatbot to be able to answer questions about your documentation, the first step, as always, is to get that documentation in the nice kind of clean format first that large language model is able to pull from.
Yeah. What would you say in the context of engineering? What makes it so difficult to prepare data the right way? Do you think it's because of the unstructured nature, or what is it exactly that makes it so difficult in engineering applications?
I think generally engineers, we work with actually a lot of data, but it's a lot of different formats, and generally the formats are quite tricky to work with. So generally, from my perspective, what I would always love is to get a nice clean data set, no missing values, no outliers, and it would always generally be in some sort of kind of what we'd call relational format. So this is where we have really clean, structured rows and columns. Think a bit like a spreadsheet. But in practice, engineers will have drawings, will have maybe some reports, maybe there'll be scanned reports, we'll have a few kind of CSVs floating around, maybe some sensor data as well. So I think that's a big challenge, and really being able to handle that in a consistent way. And then eventually you do want to kind of automate it as well, because you don't want to spend your entire time having to prepare data and not really kind of get as much into the AI side of things first.
Yeah, you mentioned some things like NaN values, and there's a lot of other things, right? Can you give us some practical examples of data cleaning and pre-processing steps that we could take as engineers to make sure our data is clean at the end of the day?
Well, I think kind of missing values is a great example, because there's always going to be missing values in data. And you've got multiple different approaches. You can just remove those examples, those rows, kind of however your data is appearing. You can remove them entirely. Another way is that kind of in the downstream AI application, you think that there's some insight in a missing value. So does a missing value mean that, I don't know, a delivery was missed maybe, or something like that? It still might have some form of kind of information value. And then we can even apply machine learning in the data preparation stage to do what we call impute that missing value. So basically to calculate that missing value based off some of the similar examples that you already have. So there's a few different techniques there, but more widely in engineering, I think kind of common examples would be things like bringing together what we call unstructured data, where maybe it has some format like a report, but it's not in that rows columns format that we really want. So being able to automate that, building a template so the data is drawn into a good format. And then other things, quite often we work with time series data. So there's loads of different data preparation steps we'll do on that. So kind of downsampling from really high frequencies, or maybe even moving from time domain to frequency domain, or vice versa. Those would be kind of quite common steps as well in order to be able to prepare the data for analysis later on.
Yeah, I think maybe before we talk about the practical or some practical applications, let's talk about the AI adoption journey a little bit. There's kind of this also, I don't know, the saying in engineering, this is like the crawl, walk, and run stage. Can you maybe distinguish the different phases and what it actually means for engineers, and how they should start an AI project, for example, or tap into AI?
Well, I think really, if you look at it, it's the same when we're adopting any new technology, especially when the industry as a whole is still working towards adopting the technology. Where maybe we don't have as many examples, there isn't as kind of widespread skills yet. And we need to build that. We need to recognize that there is an adoption journey, and we can't go from 0 to 100 immediately. So generally, as I always see it, it's first off maybe working on more historical data, more post-event data, and first off just trying to extract some insight. And I think really we can't neglect the fact that there is really good value in just having well-prepared data in preparing a good final report, bringing together information from lots of different sources, or maybe even a pivot chart. Pivot charts are great. We shouldn't neglect those either. And really, what we think of this is very descriptive analytics. We're working on data that's already happened. We're not trying to predict anything yet. We're just describing what did happen to give us insight. So that's where I always kind of start at, that crawl stage. Then we start trying to become more predictive. We're starting to run. We're going, we know what happened. We're trying to predict what's going to happen in the future, because that gives us even more information. It gives us even more power. And that's where we're applying things like machine learning. and AI, and kind of also then starting to integrate more live data as well, which does present some challenges. But then we're kind of ready for that final stage, which is where we extract that maximum insight, where we're developing systems that recommend us, kind of because they are more advanced, able to recommend the best actions that we can take. So if you're a machine operator, it's recommending the best possible settings to get the best possible output of that manufacturing process. Or maybe it might be suggesting a new material formulation that you haven't tested before. Is another really great example. But really, that's where we're extracting maximum insight, where it would take a human months, years potentially, to do what these AI systems are capable of.
Yeah. I mean, one question that I have is because with the agency, we're also building AI automations and agents. Now, for the engineering application, I think there's always this question around return on invest. How do you actually calculate it? When does it make sense to use AI in the first place? Do you have kind of a rule of thumb that you maybe go through with your customers or prospects when they're not so sure when to start adopting AI or whether a use case makes sense?
Well, I certainly think that if you think about the journey of engineering and all the steps that are involved, we kind of have building of requirements, documentation, competitor analysis, then we start developing the products. We've got manufacturing data, we've got field data, so kind of data from how things are deployed. Maybe we're getting warranty claims as well. There's so much data that there will guarantee to be an AI application in there that is valuable. But I totally agree that we need that return on investment, right? There's huge cost in building these solutions. Maybe more, in fact, the change aspect, I think, is the big one. Kind of, it's that time investment to find a new solution and deliver it. And you want that investment return. So I think in general, you're always looking for where you can measure that return on investment. That's always a big thing. And that's why use cases like predictive maintenance, for example, are really good starting points. You always see that in manufacturers. And the reason for that is because it's really easy to measure that return on investment. If I reduce my downtime by 10%, I can link that directly to increase in production. So that's a return on investment. One thing Altair does quite often with our kind of clients and our customers is that we do this thing called an AI assessment, where we come in, I guess, independently. We would speak with loads of different departments, so with engineering, with manufacturing, even with kind of back office functions like HR and finance, and really get to know, to understand the business, to understand the data sources, the objectives, the business challenges, and then build those use cases, those valuable use cases. And really the two metrics we're always looking at are feasibility, so how easy is it to deliver that on that use case, but also then that business impact. What is that return on investment? And measuring that is absolutely key, I think.
Yeah. Maybe a follow-up question on that is, do you feel like people have kind of this, people know about AI, right? They're using large language model, but their knowledge is maybe only restricted to, I know how to use GPT, how to prompt it. But do you think there is this kind of misunderstanding of AI, especially in engineering, what it is capable of and what is maybe not capable of? And also, do you feel people are hesitant to adopt AI because they're not really sure what they can do with it? And also on the other side, do you think a lot of organizations want to adopt AI because they have this fear of missing out, because competitors are doing it, they also have to do it? So how do you see that dynamic?
Well, I certainly think there's a lot of noise in the industry at the moment, kind of how everyone is adopting AI. We're seeing kind of 5 times turn on investment, things like this. But fundamentally, yeah, absolutely, there has to be that trust element. We don't want to do things. I think engineers naturally, we don't want to do things if we don't understand them. And so, yeah, we prompt a large language model, but does everyone know how a large language model works and how it returns what it returns? And certainly with these big complex GPT models, it's pretty much impossible to work out exactly why it makes the response it does. Certainly in a kind of a base case. And I think that the education aspect within the industry is vitally important, to understand that in some cases we call it AI, but it's machine learning and it's statistics, and maybe it's just actually kind of good data preparation, and kind of really demystifying it. And certainly that's something Altair has done historically. We've kind of run events and webinars on these sorts of topics as well, because I think it's something that engineers need to be able to do. I don't think, in fact, just engineers. I think kind of if you look at the workforce globally, we all need to be able to adopt AI because we'll see those benefits. But we need to demystify it for ourselves as well.
Yeah. Also have to give you guys props because when I was, I think, still a student, you have kind of this 3-part series. I think people should check it out. I can put the link in the description. It's called Data Science for Engineers. I believe it's called. This is like a 3-part series, a webinar series where we really delve deep into kind of the different topics, data prep, and then running the model, and then also evaluating it, which is really cool. So I recommend everybody to check it out. Going back to the use cases, maybe you can name a couple of those and what are the actual benefits of implementing or adopting AI for these use cases?
Well, I certainly think kind of if we look at engineering and manufacturing, predictive maintenance is always an absolutely huge one, in my opinion. Like, as I said, measuring the ROI is really important when we're first starting out with these AI use cases. And it's really easy with predictive maintenance because you think about most manufacturers, there's going to be bottlenecks within that manufacturing process. That's just a kind of fact of reality. And if certain machine goes down, that's going to cause production delays. It's going to cause additional costs because you've got to order a part on special delivery from a particular place. You've got to call out engineers. You're losing production amount immediately. So if we can start to kind of store that data that's coming off your machines, kind of maybe you focus on your key machines. We record what happened. So when did it break down? And then what we start to do is apply machine learning to go, can we predict when it's going to break down next? Because then we can do good production planning. We're on that run stage where it's predicting what's going to happen. We can make even better decisions. And potentially we even get to the point where we can build systems that will tell us kind of approximately how long we've got until it will break down again. And what you actually find when you work with customers is in some ways it's intuitive the way that they're working, is that kind of you've got people that go, yeah, that machine sounds funny, it smells funny, it's running a bit hot, things like this. It's taking information probably as humans we would understand, but it's being able to apply it every second of every day. It's able to do it on every machine in the factory. You don't need to have a person standing over it, but it means we can make those better decisions. So I think predictive maintenance is always one I look to. If you think about other ones, I always think things like report consolidation, particularly around things like warranty and field reports, particularly things engineers touch. So maybe you're getting told where we think we're having a lot of failures in the field on this particular thing, but can you actually prove it? Can you put a monetary amount to it? Because that will then define your next engineering project where you need to update the design with this particular bracket or something like that. And being able to prepare the data to maybe summarize free text fields. If we all think about a warranty claim, usually we put in a free text field. Being able to quantify that and turn that into consistent engineering topics is a really kind of another powerful use case and usually shows good return on investment quickly.
What do you think about root cause analysis?
Yeah, and I think that again, that's linked to the kind of the warranty and the field aspect approach. And really, root cause analysis is something that everyone does already. We're trying to find the root cause of a problem and maybe find a mitigation to that solution. And kind of historically would have always used statistics generally, and pivot charts again would be a great starting point. We can look one or two levels, but there's a limitation to those statistical methods. Generally, they're built on kind of assumptions such as independence between variables and things like this. And in practice, every variable is highly correlated with at least one other. So that's where machine learning again is really powerful. So things like being able to smartly segment the data, find clusters in it, filter out your anomalies, and again being able to operate at scale, because usually we don't just want to use one data set, but we want to use 3 or 4 across our business, because maybe we want to link it to our supplier information, to our logistical information, and to the engineering requirements as well. It's not just one particular piece of information that we're going to be making our decisions on.
Yeah. When we talk about data-driven versus the physics-based approach, do you feel like people still have kind of this binary behavior of thinking either one or the other? Or do you think we can kind of build a pipeline already where we combine data-driven and physics-based approaches in engineering applications?
I certainly think it's coming. I think historically we've always gone one way or the other, where we think we don't have very much data. We're going to take a very physics-based approach. And trust me, kind of with Altair's background, my own background as a mechanical engineer, it's a great way to start if you have no data, is we can use physics-based rules, physics-based models to get insight already. And if we have lots of data, of course, we can go straight to the data-driven route because we've already got that data to pull from. But I think where you see the most value is in digital twins, where really that is kind of the whole way that the industry is going, where we're pulling in our physics-based insights. We're doing those in real time, and we're combining it with data-driven results, being able to kind of update and improve the physics-based results while building on that data twin as well.
Yeah.
To have that kind of complete digital twin where we're extracting immediate insights. I think I even heard a story yesterday where kind of a company was able to identify the root cause of a problem inside a factory using a digital twin and kind of get the factory re-going within 20 minutes. And there would be no way to do that without having both kind of physics and data-driven twins working together there.
Yeah. So Altair is also developing their own solutions, right? So there's always this question about, should I build my own solution in-house or should I bring in a third party? What's your opinion on that?
Well, I think certainly we can't neglect the fact that some really great tools have come from in-house development, but there is an inherent cost to that. The cost of maintenance of in-house tools is quite high in general. When you're looking at kind of it from a software development perspective, but then also just purely from a technical maintenance perspective, you do almost need your own in-house software development team. Altair's approach has always been very much, we provide the platform that people can then build their own solutions on. So rather than providing a platform that solves predictive maintenance and just predictive maintenance, it's a platform where you can build your own AI factory to predict what's going to happen inside your real factory, but also then perhaps predict the number of sick days that you're going to have. And maybe it's also going to predict which of your customers are going to churn next. So kind of using this enterprise grade software, you don't have to worry about the maintenance of it, but then building your own tailored solutions on top of that. And generally that's the approach that we've taken.
Yeah. We had one of your colleagues in the podcast already talking about physics AI. What other solutions does Altair offer when it comes to the data-driven approach?
So my personal specialism is our RapidMiner platform. So this is designed as an enterprise data science and AI tool where you can build connected data fabrics that connect to all of your different data sources and acts as a lightweight overlay. Means that you can have complete traceability across your organization for all your data. And then we add that AI factory on top where you're starting to build kind of applications, apply machine learning and AI, and also start to build generative AI solutions on top of that. And this kind of unique combination that we've termed as our AI fabric. And really kind of the core messaging around the platform is the fact that it is easy to use. We take a kind of code optional approach to data science and AI, where we have a visual interface, we have low and no code, drag and drop. And it means that rather than focusing on having to worry about what Python function I need or what particular library I need to use next, instead it focuses on the fact that I know I need to manipulate my data in this way or apply this next technique. And we can worry about delivering on that business value first and then being able to produce a dashboard that shows those results clearly rather than having to worry about the nitty gritty.
Yeah. Can you talk about some use cases using RapidMiner?
So in terms of companies that use Altair RapidMiner, we're spread across a number of different industries. So I'd say we have public use cases with some banking financial institutions. Naturally, they have loads of data. So kind of people like, but we also have heavy usage in places like automotive and manufacturing. So Avery Dennison are a good example of that, where they've taken that citizen data scientist approach. And I think even aerospace companies like IHI in Japan are also using Altair RapidMiner to really democratize that data science journey.
Yeah. We've jumping to the future of AI. We've briefly talked about AI agents, right? Is Altair also thinking about or taking some steps into the direction of building AI agents and maybe AI swarms or agent swarms, however you want to call them? And how do you foresee the future of AI in engineering?
So certainly, yes, I can say that. So Altair, I think, brings quite a unique offering for that AI agent space. So we provide that ability to create AI agents and really importantly, again, with these AI systems, and I called it back before, they really need context, and that's what our data fabric gives. It's powered by a technology called knowledge graphs, which I really recommend looking at. All of the kind of the big companies right now are investing in that technology. And that provides really great context to those AI agents to be able to make decisions, because it provides that fully connected data. So again, we're not just having to pull from one database or one data warehouse, but being able to then kind of provide the full context of the data it needs to make a decision of what it does next. And then we provide the ability to create those tools it uses. It has a tool that it can create for predicting the next thing. I think we even have a kind of public BDR example where it's able to predict kind of why good BDRs are good BDRs, and what are the correlations between their kind of revenue associated, and the kind of different variables that are measured. So it's certainly something that I feel Altair is really in a strong position to deliver for our customers. I think on the second part of your question, kind of within engineering, we have to again look at all of the things engineers do, right? So you mentioned kind of physics AI, and that's on the simulation side of things, and we look at it, and we're trying to improve that kind of experience for those simulation engineers. We have Altair Copilot inside one of our tools, Hypermesh, where people can pull from the documentation immediately. And we have some examples of using another of our own tools, Inspire, where it's generating new code based off text prompts, and being able to then run that. So I think it's only going to go forwards where we have these AI agents where we can say, I want this information, go and fetch it for me. And then, okay, now I'm going to run my simulation because I've got that information. Maybe I've got a fatigue case study and I need a duty cycle to be able to run that, or something like that. But then after you've run it, what do you want to do next? Okay, create this report for me. And then we can run a report template and be able to get that automated report ready to go and sent to the relevant stakeholders. So this is what agentic AI and AI agents are going to provide to us. Is it just automation? No, it's a lot smarter than that, but it does provide a much faster way of working in the same way automation has done in previous years.
Yeah, when we talk about the future then of engineering jobs, how do you think that will change? Do you think AI agents and automations act more like augmentation of our own capabilities, or do you think some of the jobs will also be kind of completely substituted?
I don't think jobs are going to be completely substituted. I think we need to have that credibility, right? We're designing the world as engineers. We're building products that people are using every day. Needs to be trustworthy. There needs to be checks and balances in place. But I think it's going to be another of those tools that naturally people are going to pick up. And the same thing's happened in engineering for decades. If you think, kind of go back 40 years, engineering simulations was something that a select few people did. You needed a computer the size of a room. You needed a PhD to be able to do it. You needed to put in punch cards. And kind of these days, with a standard workstation, you can run a full crash simulation. And I think the same thing is going to be true of AI. It's going to be another tool that engineers are going to need. It's going to be something that employers are looking for. But it's just going to augment what we already do and make us able to do far more in a day than we ever were before. Whether it be using AI to predict a simulation result, so we have to do less physics-based simulations, or maybe it, as I said, kind of is drawing on from other information to inform us better, or maybe it's working on the manufacturing line, whatever it might be. I think it's here to stay, but it's not going to replace people.
Yeah. Do you feel when we talk about the topic of democratization, I know a couple of years back, engineers who are really the experts in CFD or FEA, for example, they were quite pissed about people overusing that term and saying that everybody can be an expert overnight, so to speak. Do you think, if we think the same way about AI and AI agents, that maybe we want to democratize the solution, right? But do you feel there's also a negative side of it?
I don't think it's a negative. I think we just need to make sure that it's done in the right way. And you certainly want the experts involved in it. I think that just to be clear, democratization doesn't mean that we exclude the experts. If anything, I always say that the experts actually become more important because they become those central lighthouse figures that people build around. So you're always going to have experts within any particular domain, and you're going to have AI and data science experts, your data scientists within organizations. But they don't want to be spending their day having to write a Python script to prepare the data because some engineer has come to them saying, I need this yesterday. They want to be working on the really cool stuff, the really high value stuff, that full sprinting stage on our kind of maturity curve. And they can do that. And for example, Altair RapidMiner is kind of a platform designed to do that. So it's democratizing and it's collaborating. But in general, I think it's in simulation I see it, where you've got your FEA engineers, the really experienced ones, the analysts. They're making sure that the end simulations are correct. They're doing the certification, signing it off, saying this has been done correctly. But then you have the designers going, I can do a quick simulation to see if my design was better, because there's no point sending a rubbish one off to the FEA analysts. So you're taking workload off the FEA analysts. And I think in the same way for data science, we're taking that kind of mundane workload off them, but also making sure that they're involved in everything that everyone else is doing.
Absolutely. Maybe to wrap it up, Roland, any recommendations or tips maybe for the audience who want to tap into AI? Maybe they have already explored a little bit of AI in engineering applications, but I think Altair is already giving a lot of resources to people who want to tap into AI. Any recommendations from your side?
Well, obviously, kind of, I'd promote Altair's kind of marketing, and some of the stuff that we do around kind of webinars and events where you can come and learn. But equally, I think just staying within the wider industry, understanding what's going on right now. So whether it be attending a public webinar or listening to a podcast or reading an article, it's always good to stay informed and see what's happening. And then I think it's just about trying to find some use cases to get started on. There's loads of examples now kind of hitting Google. If I do a Google search on engineering for AI, I'm sure I can find some great use cases immediately. It's just thinking about, what do I do day to day with data, with information? How could I make it better? How could I make it faster? And speak to your colleagues as well. Maybe you think you don't have a problem, but they're going, you're spending 4 hours doing this task, and it takes me 10 minutes because I'm already using this AI tool. So I think speaking to people as well is always a really good starting point.
Yeah. How do you keep yourself up to date with the latest trends in AI?
So certainly I would listen to podcasts. I always try and hear about the latest things. So obviously, yes, we've mentioned it a few times. AI agents, the big one. And then I just try and go and educate myself. And I think always the way is to try and build and learn, and probably fail a couple of times as well. But kind of trying to do something with these tools is the way that you can get started. And maybe it's a simple dummy problem just to see that, oh yeah, that's how it actually works. This is the return I could get. But as soon as you start with these use cases, very quickly it sparks a new idea of maybe I could use this technology in this area. Maybe actually I could use it for my job right here. So certainly I just try and keep listening, keep learning. Every day's a school day.
Yeah, absolutely. All right, Roland, thank you so much. I certainly learned a lot in this podcast, and I'm sure people will enjoy it as well. And we'll put all the relevant links and resources in the description of this podcast. Anything that we might have missed, Roland, where you think we could have talked a little bit more about?
Well, I think certainly the one thing I'd always emphasize is getting started is great, but just make sure that you pick that right use case. It's so easy to jump in, try and build this all singing, all dancing AI application, but then maybe it falls flat. Maybe you lose stakeholder interest. So I think always having a good use case with a good measurable business case behind it is really important. And then also, I think we need to acknowledge the fact that with AI, there are some concerns about why are we making certain decisions, and we want to kind of balance that. We want to use this new technology, but make sure that we're understanding why it's doing what it's doing. So to always remember that as well. When you're building these solutions, we want to explain what we're doing and why we did it.
Absolutely. Roland, thank you so much for this podcast episode.
Thank you very much.
Hopefully we'll have a second one.
Hopefully. Thank you.